Hey guys, welcome back. We are moving on, doing some other examples. Now they are going to be a little complicated, but not that difficult. Okay, so what we're having now is we're having the limits. We are finding the limits when x goes to 0 of x cosecant of 9x divided by the cosine of 12x. Oh, sorry. 12x. Okay, this is a nice example we're going to do now. Okay, all right, but before we get started, we're seeing here we got a cosecant, right? And we know that the cosecant of an angle theta equals to 1 over the sine of that angle. Okay, so we might need this one here. Seems like we can write this one here in here and then continue with our exercise. Okay, so this is going to give us then, if we rewrite it using the secant like this, the cosecant like this is going to give us the limits when x goes to 0 of x times 1 over the sine of 9x, okay, like this, okay, over the cosine of 12x, alright, and this right here equals to, it is the limit of, or let me just take it a little backward to have some more places. Okay, and this is equal to the limits x goes to 0. We're having two division. Okay, we have x over the sine of 9x and cosine of 12x over 1. This is almost the same. I mean, this is what we've been doing the whole time. You know, when you have a over b over c over d, you can turn that into a multiplication, and that will give you a over b times b over c, and that's what we're going to do here. Okay, so we will have x over what we got here, the sine of 9x, okay, times 1 over the cosine if you want. Okay, so I'm going to just, you know, just write it here together with that one here, cosine of 12x. Okay, then to make it look good, I can do it like this. Oops. And then, all right, okay, looks beautiful now. Now let us just try. We just, we haven't started, to plug the zero in it. I mean, to find the limit. We just try, to interpret the information we had here, okay, because we couldn't use the cosecant here. We just turn it into a sine, okay. And now if you plug zero in there, it is zero, and at the bottom is going to be 0, 0, 0 over 0, and this is it's giving us 0 over 0. Now we need to use the L'Hopital's rules, right? We need to use the L'Hopital's rule, and this is going to give us, it means that we're going to take a derivative, of these two, both the numerator and the denominator. Taking the derivative gave us, if we take the derivative of the numerator, it is 1. Alright, it's 1. And now we're taking the derivative of the denominator. This is a product, so we're going to use the product rule, okay. And the product rule tells us when you have u times v prime, it is equal to u prime times v minus a plus, excuse me, u times v prime. All right, so u and v, that gave us, so the derivative of sine 9x, this is a chain rule to do that. It is 9, and the derivative of sine is cosine of 9x. times cosine of 12 x, now plus derivative of the cosine is minus sign. When you go, do clockwise, the derivative go down, it's minus cosine. Okay, and it means that that one here can change into a minus. So we have in here minus. So the derivative of the cosine is minus. That will be 12 then. Sine is minus sine of 12x. Okay. So derivative of the sine, that we have 9 cosine 9 times cosine 12x minus 12 sine 12x. Okay. And times, okay, and times u times sine of 9x. Okay, it's a lot. That's why I was about to forget it, but everything's okay. Yeah. So now we can try again to to plug the zero in it. Take a different color to see what's going on here. So if I plug the zero in there, I will have 0, and the cosine of 0 is 1. This gives me 1. And I plug 0 here, the cosine of 0 is 1. This gives me 1. And then I still have 9 here. And if I plug 0 in there, the sine of 0 is 0. Okay, I have 12 here. If I plug 0 here, the sine of 0 is 0. So I'm gonna have 9 minus 12 times 0. This whole thing, 12 times 0 is 0. Okay, so this whole thing here goes to 0, and that one goes to 9. It means that our final result will be the limit. I don't have that color. Okay, the limit when x goes to 0 of x cosecant of 9x over the cosine of 12x equals to 1/9. Alright, okay, and that's our final result. Okay, so our next example, so before doing or taking our next limit, let's just make some rules here. Is just to wipe it out. Okay, then sorry, I'm gonna have alright, my next example, in terms of start here to show that as an example. The next one will be I'm gonna have the limits x goes to 0 of 4x plus 4x times cosine of 4x over the sine of 4x times the cosine of 4x. Alright, looks complicated, but it's not. It's pretty easy. Okay, before starting to do anything, let us just try to plug the 0 in it to see what it's going to give us. If you put 0 here, it's going to be 0. It's going to be 0 here times the cosine of 0 is 1. The whole thing will be 0 on the numerator, of course. If you put 0 here, 0 cosine is 1, and 0, 0, it is 0. It is 0 over 0. Okay, so what we're going to do here, we're going to take the derivative of both numerator and denominator, and that's going to give us the limits. X tends to 0, and the derivative of 4x is 4. So, and now we got here a product. This is a product, and in the product we have a chain rule. Okay, so the derivative of the product, this is what we're going to do. We're going to do this one here times that one. Okay, so plus this one times that one. So that gives us, they got a plus here. First of all, the derivative of 4x is 4 times the cosine of 4x. Okay, plus the derivative of cosine of 4x, it is minus, right? So that's why I'm going to change this one direct and straight to a minus. Okay, so the derivative of the cosine is minus, then I got a minus, and 4 sine is minus sine of 4x. Okay, and times 4x. Okay, so what we did, we took a derivative of this one, it is 4 times that one, and now we took a derivative of this one, this is 4 minus 4 sine 4x times 4x. Okay, so we're done right there. Okay, and now at the numerator we're having a product, and in the product we have a chain rule again. So we're going to take the derivative of this one times that one, and the derivative of this one is 4 cosine of 4x times the cosine of 4x. Okay, plus the derivative of cosine. Oh, okay, this is giving us a minus, so I have to write minus here straight. Okay, the derivative of the cosine is minus sign, so we're going to have here minus, and taking the derivative using the chain rule here, it is 4 sine of 4x times sine of 4x. See, it's not that difficult. Okay, so now we're going to try to plug the 0 in it, okay, to see what it's going to give us. Okay, if you put 0 here in here, first of all we have 4. Okay, so let us just do it like this. We're having 4 here plus 4 times, we plug 0 in here, it's going to be cos of 0 is 1. We plug 0 in here, so minus 4 times plus 0 here, this is 0, and times this one 0. So the whole numerator is giving me, I have here 0, 4 plus 4. What about the denominator? We put in 0 here, we got 4 first of all, times, plug in 0 here, it gives me 1. Okay, and plug in 0 here gives us cosine of 0 is 1 again, minus 4, the sine of 0 is 0, and the sine of that other is 0. So we have a 4 here minus 0 times here and times here minus 0. Okay, our whole result will be giving us the limits when x goes to 0. Oh, we don't need limit anymore. I'm always doing this mistake. I'm sorry about that. Okay, so we have at the numerator 4 plus 4 over 4 at the denominator. This is the only one we have in here, and we're taking this one here, this one here, and this one. Okay, because this is this one, all those one are 0, and this is equal 8 over 4, and that's equals 2. Okay, so we can say that therefore the limit when x goes to 0 of 4x plus 4x times the cosine of 4x over the sine of 4x times the cosine of 4x equals to 2. Okay, and that's our final result. Okay, thank you for watching, guys, again, and until next time, bye bye.